I'm Clayton, working with Covenant Technology Partners. I've stopped that in May and started my own company focused primarily on BI and SQL Server and the technology surrounding that. And I'd signed up a long time ago to do this presentation and tried to get some time in on cluster and column store indexes and learning it. And the more I dug in, the more I found out that there was to learn. So there really needs to be another, like a 500 level topic. And I found a guy at SQL Pass to present it. I might try and contact him, see if he could present that level, because he did a fabulous job at Pass and really going deep. So if there's interest in that, indicate that on the survey, and we can try and get someone to talk at a much higher level about these tools than I can at this point. So a little bit about me. I'm a father of 4 kids. I've worked with SQL Server since the early 90s. I focus on analytics and BI, and I love problem solving. I'm an independent contractor now, so it's just me. There's a few other of us in the market. I see John, one of my friends here, does the same sort of thing. We take care of each other and share leads and make sure that everybody's got enough work to do. I also love doing data visualization work, so if you have needs for dashboards or reports to tell a story, that's something, a quick hit type project that I like doing. And please eat the pizza. I don't want to take it home. Kids will not like the fancy pizza. They just want the cheese pizza, so please enjoy the pizza. Let's get rolling. Topic today is the in-memory data warehouse and column-wise indexes. And I got a couple slides up front. I got to thank people like Eddie for getting me technical slides from Microsoft. It's always nice to have nicely drawn pictures instead of having to draw them yourself. So these particular technologies were first introduced with the VertiPack engine in Power Pivot for Excel. And that engine got transported into and included in SQL Server 2012, and 2014 they've added to the capabilities. What it does is it takes the data, instead of storing it row-wise, stores it column-wise. And what we're going to go through today is some of the mechanics of that, how it works, some of the gotchas, and how to get around a little bit. How many of you are familiar with heard of columnar index databases? All right, we've got a few. Sybase IQ is the first one I ever worked with, and it was cool. This was back in like 96, I think, 96, 97 time frame, and it was really neat. You could push, 100 million rows into that thing, get answers, boom, boom, boom. So it was pretty slick. Enjoyed working with that, but now we have a technology that's much more scalable, and it comes on the standard or enterprise SKU of SQL Server. Big benefits, 10 to 100 times faster. We're going to do some demos and see the stats for yourself on how that works. And it also is a lot simpler approach to getting performance gains than trying to do this all with indexes and partitioning, managing queries, and a lot of other tricks you end up doing. Other traditional models for storing large amounts of data, obviously relational databases, star schemas, so dimensional data warehouse, and more currently MapReduce, or your key value pair storage of data that's pulled off of data. So there are other ways of doing it, but the in-memory column store model has a lot of advantages to it, and it sits right on top of the SQL model. It's part of the engine. You don't have to learn any new query language. You can still write the same SQL queries and get much better results. Yes, Phil?
Clayton, is SAP HANA, is that the same thing?
Very similar. It is an in-memory database, yes. Yeah, and I have a friend who works for SAP. If you want more details, I'll send you his way on that. I don't know enough about HANA to give you any good answers on that. So it's basically everything's compressed so that more can fit into memory. You don't want to have a huge amount of memory on your system. This allows you to use standard buffering capabilities, paging in, paging out of the SQL engine, but with compressed data sets. And each column can be accessed independently, but it can also be gotten at row-wise in terms of the query results. So it really can reduce I/O. For example, if I run a query that only hits 3 out of 20 columns, it only hits those segments, those chunks of that index. So the column store structure has 2 key parts to it. They are segments and row groups. So every column is broken down into a separate set of segments. And those segments are broken down by row groups of about 1 million rows each. So each row group / segment intersection there represents about 1 million rows. So if you load a table from scratch, it's going to have 1 million row segments and one segment that's partially full at the end. And each of those segments are compressed at the time that the index is built, and then they're stored as large objects on disk. And the unit of transfer is that segment. So it's read and write to disk is going to be a segment size. So how does that look? What does that mean in terms of what happens to a table? So if I start off, I have a table, I've loaded, it's created. In this case, I've got 6 columns and who knows how many rows, say 100 million rows. It's going to, first of all, horizontally partition that data into those row groups of approximately 1 million rows each. And then it's going to further segment it vertically into the columns. So now each segment is defined as column X, this particular range of rows, and then the next step is to go and actually compress the data in each one of those segments. And there's about 6 or 7 different technologies that are used for the compression, depending on the data type, depending on statistics of the data in those columns. So one of the key takeaways from this is to maintain your statistics well in the database so that the optimizer and the compression engine can make the best choices for that. So once that's done, it's written off to disk. And when you write queries, it's only going to fetch off disk the segments that represent the columns in your query. So in this case, we're only getting product key, sales amount, and order date key. So it's going to eliminate the columns we don't need. Furthermore, it's going to look at our where clause, and then based on row information, eliminate segments from those tables that don't match up to the where clause. So again, it can very quickly, at a high level, based on the metadata about the segments and the row groups, eliminate huge amounts of I/O from the process. So this is really where the performance comes in, is being able to say, hey, I only have to read a little bit off disk instead of a whole lot. The compression, you still have to deal with the compressed object, the compressed structure, so there's overhead for the CPU on that. But as far as the disk I/O, which is your biggest pain point on any database, it virtually minimizes that as much as possible. One other big change with SQL Server 2012-2014 is the introduction of batch mode. So if you're someone who looks at your query plans, you see batch mode show up, and think, is that good or bad? It's a good thing, trust me. There are some rules around making sure that your queries end up running in batch mode. Typically, it's going to be the bigger queries over larger data sets. SQL 2012 had more restrictions than 2014. So if you're able to get to this technology, the recommendation is if you're going to do it on 2014. It's here now, and it's much improved over the 2012 version. So if you're an enterprise customer, enterprise licensing, you're going to go with this is a technology I highly recommend. Skip over 2012 if you have the option. It also has added a lot of capability within batch mode to improve parallelism. And it deals with, instead of single rows at a time, iterating over a single row, it works in blocks of, I think it's 1,000 rows. So it's a much faster process. So it's processed 1,000 rows at a time, and things are stored in a vector form, and they're optimized to fit into the LU cache of the CPU. So that 1,000 rows at a time is going to fit in the CPU cache where the vector operators are implemented, so it can happen very, very fast all within the CPU. And they've also added support for filter, hash join, hash aggregation, and can increase your CPU time, CPU utilization effectiveness by 70 to 40%, 40 times. In-memory column stores. In SQL 2012, column stores were read-only. So once you created a column store index, it sat on top of a base table. That table could have no indexes on it, no primary keys. There's some other restrictions around data types. But the index is a separate entity that you could not touch. You couldn't update the table. You couldn't change the index. you'd have to disable the index or use partition swapping to move new versions of the table in. So 2014, they solved that problem. It's really cool, the approach they took and how it works. And I don't think any other vendor took this approach, and we'll step through it. They've solved the problem very, 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 from an algorithmic perspective, a very cool way. So with 2014, with a clustered column store index, you don't need a base table. Your table ends up being restructured as an index. You can insert, update, delete data. You can eliminate the need for any other index because your entire table is a column store index. And you're not going to get any faster than that. And they've added support for more data types in 2014. So space savings. This is a really telling chart of what impact you can see in terms of allocated space requirements in your database. So customary indexing on a 4 gig, say a 5 gig table of data, you're going to almost triple that. You're going to have almost 20 gig storage, including all the indexing and overhead. So you use page compression, that'll bring that down to about double, so about 10 gig. And if you use a table with no indexes and page compression, you might knock up about a gig, get down to 4 gig. If you go with a column store index on a clustered kind, you got your base table of 4 gig, plus you've got to add on top of that about 1.9 gig for the clustered column store index. Whereas if you go, the column store index, if you go with a clustered column store index, everything's going to fit about that 1.8 gig. So you take that large fact table from being a 5 gig table down to just 2 gig. And it's a fully functional table. How often do you do updates against the fact table other than adding new rows? Not very often. So there's some good techniques, and I've got references at the end to the blog post of the guy who mentioned earlier has great in-depth posts on column store indexes. I'm not even going to try to present his stuff because he did such a fabulous job to pass. He almost got a standing ovation. People were like clapping all the time for him. He showed how to make sure these indexes run as efficiently as possible, no matter how many updates and things happen to them. So, yes?
Do you happen to know which edition? Is this an enterprise edition only?
This is an enterprise feature.
Of course. Of course.
I know. Eddie left. Eddie's our Microsoft SQL Server rep. I don't think he has any swing with the marketing folks on that, but you can always try.
Awesome, cool stuff is on enterprise. They did it on purpose. I know.
And they've added them to SQL Azure as well. So there is. I don't know if it's in the current build, but in the future build of Azure, they've announced that it's going to have column store indexes. So that is coming in the online edition as well. And that only makes sense. It just makes that version that much more effective and memory smart. All right, so the structure, how it works. So it's very much like creating any other index. You say create clustered column store on table, and with whatever options you choose. There is no column list because you're turning the entire table and all its columns into column stores. Bulk insert is supported. So bulk insert is smart enough to break itself into million row chunks and load them in and create the segments in effect on the fly as it's loading. So the overall structure of this, and I'll walk and point to the slide, is we have our column store, but then to support the updating, there's a row store. So if I insert a new row, it doesn't go into the column store right away. It goes into the row store where it's just a B-tree table, typical heap type table. And then there's a delete bitmap, just a flag in effect that says this item's been deleted. So if I run a delete operation, I'll get delete bitmap items showing up against that segment. And then the row store, once it hits a particular threshold, there's a monitoring process that runs about every 5 minutes, the tuple mover, and it'll check and see if any of these have hit the threshold, and if they have, they'll convert them into a segment. But once it's a segment, it's not touched. It's never touched again. Okay, so load our data. We now have a bunch of column stores there. If I start doing some insert, delete operations, So inserts get to the row store, then the tuple mover moves them in, and then if I do any deletes, if they're still resident in the row store, they're deleted. If they're already in a column store segment, then they're deleted, flagged as deleted in the delete bit now.
Hey, Clay.
Yeah.
How often does the tuple, what you call tuple mover, how often does that run?
Every 5 minutes.
Is there any settings on that? Can you?
That's one of the tricks of this guy that I blew my mind in this presentation is I didn't think you could force it until it hit that, there's a threshold, X number of rows for it to rebuild the index. But he found out a way to force it to start the tuple mover and move things. What can happen is if you're running this on a big table and almost treating it like an OLTP where you're doing a lot of updates and writes and reads and writes and deletes, this can slow down your performance. So you could actually end up with worse performance than on a regular table because each of these segments is being degraded in effect and more data is showing up in the column store, and a million rows is a lot of rows. And so if it's having to go up here all the time to get data, it's going to impact your performance. So you might end up with less than the 100,000 row set point that it's looking for, and across a bunch of different segments, it's going to affect your performance. And what he came up with was a way of forcing the row store to be pushed into a segment and also to rebuild segments to compress them back down. So it was pretty neat trick. I'm not going to steal his thunder. I'll point you to his blog. If you want more detail on that, make that a topic, and I'd be happy to work with him and get a presentation on it. So another way of looking at this was from a white paper from the development team, is the row groups, segments are immutable. You cannot change them. They are fixed. Only the delete bitmap, which is a B tree, and the delta store, the row, are changeable. They're the only things you can touch and affect. So it's pretty simple. If you think about it, once it's in a segment, it doesn't change until you rebuild the segment. Yes, sir.
In a case of a reboot, I guess that's all systematically flushed, so it goes to the column store?
Yeah, so that, even though it loads it into memory when you need it, it's not only existing in memory. It's still written as large objects on disk. So in the demo, I'm going to create tables from scratch, basically. So it's building the segments from nothing, and it takes a little while, but once they're there, we can step through all the different examples, do deletes, updates, whatever we want, and see the impact of that. So again, batch mode, 2014, they included some more capabilities to it. So all flavors and joins, it was limited. There were some limits with union all that kind of made it kind of pointless. With column stores in 2012, it was like all these little gotchas that by the time you got to the bottom, it's like, well, was it worth it or not? 2014, they took a lot of those away, and it's definitely worth it to do a proof of concept, try this out, and see what your results are. Again, if you're looking at your query plans, you'll see in the execution mode. And I have to recommend SQL Sentry's Plan Explorer tool. It's free. Go download a copy. It's a great tool for monitoring and tracking your queries as you're tuning.
Clayton, are you still presenting on the link? It's not showing.
Does not look like it. I wonder at what point that went away. All right, Outlook. Well, you guys can't see that screen, so what I'll do is, just for the crowd, the audience here, let's turn this direction, is I will show you a couple of the web pages that are in the reference list. Joe Slack has a great site here. There's also one, this Nico. See, Nico Newgaber. He has all of these posts on Column Store, and he goes into the nitty-gritty. This is the one that I highly recommend you take a look at. Look at this. part 1 through part 45, just on column store indexes. And when he presented a path, he covered this little slice of what he has in his thoughts. And I've been trying to get through them, and just, it's a lot of time to spend, but wow. I mean, he's got what's going on underneath all figured out. So this is definitely one of the starting points. There's also, find it here if you have it. Yeah, this one is a FAQ that's on TechNet, SQL Server Column Store Index FAQ. It has links to tons of other ones as well. So I only have a few in the reference list because the ones I found, so many other resources, you'll be swimming in them for a while. Did I see a hand? No. All right, our conference call does not start. Julie, can you? There he is.
You're right, you know him probably.
We lost the presentation.
Perfect timing. Oh wait, no, it's down one way. It's down one way.
One moment. There's one person online, so I was confused.
No, I have another person trying to connect.
Feedback to turn here. So who are our SQL Bits presenters today? Why don't you put your hands up? All right, so we got 4, 5. Awesome.
Yeah, okay, I should get them ready.
Well, depending on the time,
Let me know.
we've got 6 presenting.
6? Wow.
Yeah, you might need to reconnect. I can't even make you presenter. You've lost all your credentials. We still hear you though.
That's interesting. Well, it's going through the sound system. So like log out of blank entirely?
No, just I kicked you out of the meeting so you can
Okay.
rejoin it.
Is link the issue or is it?
There's a lot of moving parts in the link product between his laptop, connectivity in, servers out in Redmond, back to here.
I use it
present,
every week.
record, and talk to him.
It's only here that it gives us trouble because I use it every single week.
Get Windows 7?
Windows 8.1.
One. I'll tell you. I can present. The link guy's in the hallway if you'd like to call and talk to him. He always left us here.
I'd hate to be that guy.
Yeah.
All right, it just says on mine, just says starting. So let's go ahead and proceed. We're almost done with the slides. In the demo, I'll post the queries and that for that as well.
I don't even see you back in the meeting at this point.
Yeah, it just says starting. All right, let's go back to the slides. All right, this is a topic that I don't really, it's one of the marketing slides that I don't know much about, so I won't talk to it. And if anyone else wants to in their talk cover this, they're welcome to. But the big thing is that global batch aggregation is a new operator in the engine that replaces several other operators that were in existence. And so you will see this sometimes showing up in your query plan. But it's not something I was too much aware of. But it's another performance enhancement in 2014 related to the column store indexes. And archival compression. This one's kind of fun. This is, how many of you do tiered storage on networks or for databases or anything like that? Susan? So this allows you to do tiered storage with your column store indexes, in effect, by saying, I want these partitions to be further compressed because they're an archive. So if I have 10 years of data and I only want the current 3 years to be easier, faster to get at, I would leave them standard column store. But for the other 7 years, I can make them archive. It's another option in the
It's by a partition, or can you do it on the table too?
You can do it on a table as well, but you can do it by partition as well. It's just an option. And so what it does is basically doing limp zeb or zip compression on the segments as well before it stores them to disk. And just to give you a little chart what that looks like, took the stats and plugged them into Excel and did a little chart for you. And so compared to gzip, the same data, the archival compression does a pretty decent job of storing that. It's an internal Microsoft implementation, basically, of zip, limp zeb compression specific to this task. So these are the compression ratios. You can see you get pretty decent compression ratio on various database sizes. All right, so partitioning column stores. It's just as usual. You create your table with your partitions, and then you create your column store index name on the table, and it will create a partition. So it's going to handle that a lot simpler than you would expect. It's a very simple mechanism to be able to create those over a partition table or over a standard table. So again, bulk insert is automatically going to create groups of 1 million rows and fill up those segments as it's building them. And if there's anything under that, under 100,000 rows, it doesn't create a segment. It sticks them in the row store for possible addition of additional rows. But again, you can't run a command that will force it to flush those if you want. And then it's automatically moved. So the tuple mover, when the row store reaches 1 million rows, it's going to do that conversion to a column store group. And again, every 5 minutes. And you can also force it by running an alter index name on table reorganize, and it'll force the tuple mover to start. So building it is definitely memory intensive. You think about what's going on behind the scenes, is it's doing all the work of compression and creating those data structures and then writing them out to disk. It's taking and doing a lot of work that requires that set of rows to be in memory for it to work. Unit of parallelism, again, it's a segment. So if you have a lot of CPUs, you can throw them all at it. If your degree of parallelism is set high, this thing can happen very fast. If that causes you memory issues, you can dial back the degree of parallelism, or you can set a memory grant request, set the request higher before you run, set it back. Other options, give yourself more memory, set your max memory higher, or reduce your parallelism, like I said. And in summary, so with 2014, you get clustered and updatable indexes in memory column store. Archive option has been added, and then the global batch aggregation operator. Main benefits, much faster, more real-time data warehouse engine. And one of my pet projects is to test writing OLAP queries, so take the same data set in analysis services and then run my MDX query against that, and then do the same thing against the data store using windowing functions and various things to arrive at the same types of calculations. This time last year, I presented on windowing functions and how to do like year-to-date, month-to-date, all kinds of slices of time using a standard time dimension in the windowing function. I want to test that with these and see if I can get similar performance to a cube. And why that's important is that's one less technology I have to support with my data warehouse. If this is going to give me nearly the same performance, then I don't need to have analysis services engine. There's other advantages to that. There's different strengths and weaknesses of both platforms, but for some cases, that might be good enough. You might not have to go to an analysis services to get that level of performance. Disk, again, I/O and disk saving is huge with this. Big benefit. And again, just better performance, more efficient use of memory and your processors. So some of the limitations, these are primarily the 2012 version, although some of them do apply to 2014 for very logical and reasonable reasons. 2012 was non-clustered only. That's not the case in 2014. Tables were read-only. That's been solved. They're updatable. So in other words, if you want it in 2012, you either have to drop the index or disable it, make your updates, and then re-enable the index. It must include all tables or all columns in the table. There's no filters, no filtered indexes where you can create an index that filters out to a subset of rows in the table. That's a very unique kind of index that's not supported. It really doesn't make sense. You don't need it. And there's no include option because there's no column option. You don't even tell it what columns to use. And it cannot be used in index views or materialized views. Again, it doesn't make sense. We've already done the best possible job of compressing and organizing that data as you can. And there's no custom-defined sorting, which uses external code to do that, add on to the engine. And there's no support for page or row compression, which again, logical, it's already very fast. Yes?
So for anybody who used it in SQL 2012, was this just to use for static big archive reporting tables that, or not archive necessarily, but big reporting tables that just don't change?
Yeah, if you had a warehouse and a nightly load, you load the data. Before you load it, you drop the index. You load the data, you recreate the index. It's part of your ETL window. So it had purpose and it works in certain scenarios, but it's a limited number of scenarios. Other thing, no sparse columns, which again kind of makes sense. No unique column store index, so you can't create a unique index on a column store. You have to handle that in ETL. No support for replication because you're not dealing with rows, you're dealing with large objects or disk. And there's no change data capture, change tracking, or file stream support, column support. 2014, index changes again. We get cluster column store. They're updatable. And we have clustered and non-clustered support for unique identifier data type. Data types. There are unsupported data types, and these mostly make a lot of sense. Unique identifier, I don't know why that one didn't make it in initially, but it didn't. It's in 2014. Text data types, that's kind of obvious. I wouldn't want them in an index anyways. Varchar max and varchar max, again, those are, in effect, a text object. Row versions and timestamps are very unique things that aren't going to really compress. It doesn't make sense that they'd be in there. SQL variants, CLR types, which are user-defined types. Of course, you'd have to write the engine to handle them, so it's obvious they're not in there in XML. And very similar list for the same reasons for 2014. All right, demo. Let's see if we can get out of the deck here and run some queries. We're doing all right on time.
Do you want to try to bounce back out a link real quick and jump back in, see if we can get you presenting again?
Just saying, starting. Let me do this too. Let me switch to just one screen. Since I'm just writing queries and I can see it too.
Yeah, I don't even see you in the meeting anymore. I do. See Julie in there? see Mike Kim.
We'll try the hardware again. So Petro that's on?
Yes.
Kim?
Morales Sombra.
Hi.
Hello. You're going to be our AV tester.
Well, I just got an email.
Okay.
It's not going. Reboot?
I got your IM, but
Start and stop, or maybe log out a link and back in.
All right, I'm going to total close it. Start. Looking at my calendar.
Oh, we have such problems. Somebody has happened to they don't have an issue.
Okay, we're getting. You see something now?
You see, I still don't see anything. We're working on getting this presentation back online.
okay, it's loading something. Hopefully.
There we go.
All right. I'm able to see your
now
screen.
I'll be able to see it though.
Nobody else can see here.
I don't
Why not? Duplicate.
take it out and take it.
Should we just hover around chairs?
Yeah, let's everybody come up here for a minute. And we'll,
I don't see
I think we can fix that.
There we go.
How's that? And we didn't lose link. Yay. All right, so what I did to build the examples is I started with the AdventureWorks demo database from CodePlex.
TechNet?
Not Technet. You go download it off codeproject.com.
Code Project,
It's not Code Project.
CodePlex.
I said it right the first time. Yeah, CodePlex. So you can download it. But Atom Mechanic has a nice script for creating a large table because a lot of times it doesn't make much sense unless you have several million rows to be able to try this out and test it.
You need a million just to start, right?
Yeah, just to start, and you're kind of really just twiddling your thumb. So he's got a script here that will generate 25,000 product rows and 31 million transaction history rows. So that's my starting point. And I've got the link here, and I'll do a post with a link to these files on my blog, which has no post on it because I just got it set up last week. It's SQLmonger.com, SQLMONGER. So my first one will be get some notes about this up there with the links and references.
And your presentation too?
Yeah, I can put the presentation. That'll probably go on the past site.
Yeah, I'll upload it to our archive site, the presentation.
Yeah. And so that was step one. So I took his script, built out a big table, and then started working on looking at that. So what I did then was create some big tables. Well, I'm going to go ahead and drop those right now. So make sure we'll use the right database. And I'm just going to drop those tables. And it's only going to take a minute to rebuild these, 37 seconds. And I'm going to run all of these, and then I'm going to pop up, because it'll take about a minute and a half for these all to run. But I'm going to pop up my performance monitor so you can see what's going on. If you're running some of these tasks normally, I've got 4 CPUs. Normally they're not that busy. One of them will spike up because it's not doing something it can do in parallel. But because I'm building this index in parallel, you'll notice when it gets to about the end, it's going to totally saturate all CPUs. So it's when it does that segment compression, it just hammers it. So it's something to be aware of the impact it's going to have on your server. It's definitely going to take all the resources you have if it needs them. And you can end up with running out of memory. And the easiest way to throttle that back is to set your degree of parallelism down a bit so it doesn't try to run as many things at once. But it does a phenomenal job of just taking advantage of all the resources. So why I'm doing this is I wanted to create those column stores and segments clean, boom, full 100%, and make it so that our starting point before we do any deletes or anything is a nice clean start. And again, I'm running this on an i7 laptop with a Intel Core i7 dual core or dual quad core basically, and 12 gig of RAM. And it's still going. So our tables have been created, and now it's working on indexing. So sorry I had to make you wait, but I wanted to have a nice clean start, show you how I did it. If you want to replicate it, it's not real hard. I just did a select into 2 different tables with different names so I can apply the different index types to. And then basically what we're going to do is walk through some basic types of queries and snag the performance stats and show you what those look like. So, done? Still done?
Done. Yep.
Done? All right, so 2 minutes. Not bad for creating how many million rows? 62 million rows. There are 3 DMVs that are included for column store indexes, and they show you some basic stats. There's a lot of really good queries out there, and I've got, I had a window with one that show you more details by joining 2 partitions and give you the object names. So you can get a lot of detail about the partitions themselves and the segments. So you can see, are my segments getting fragmented? In fact, do I need to do a rebuild? So the monitoring tools are in place to be able to look at what's going on behind the scenes. So again, new DMBs to be aware of. All right, so that's our setup. We've built the indexes. It's all ready to go. So now I want to do some performance comparisons. And I did a little spreadsheet. And I'll show you the results that I came up with in my initial testing. Let's just zoom out a bit. And what we'll do is we'll run a series of queries, capture the results, plug them in, see how they compare. So I have a nice blank chart you can do that with. So the first task is I want to make sure nothing's cached. So I'm going to run, first of all, make sure you get the right database. Just drop my clean buffers and free proc cache. Set my stats on. And our first query, as you can expect, this is our table with no column store indexes of any type on it. So we're going to run that, and this one takes a little while. Typically it was about 20 seconds. Any questions while we're watching the clock spin? And we're done. So 23,000, so 23 seconds. Get that in. So now, So how long that took? 24 seconds, approximately. I'm going to go ahead and run the next two together. You'll see the difference. So that returned the result in not even a second. So let's see, first one's 327, next one's 260. 327, 260. Doesn't even show up. So again, we want to clean our buffers. Next test was a filtered count. So let's just hit that table and get specific products. So all I'm going to do is filter my one table. I'm not going to do any joins. That's not too bad, right? Okay, 103 milliseconds. I'll remember. Oops, I'll put it. Next two. $29.36. I'm getting the right one. 29.04 and 29.36. 29.04, 29.36. Virtually identical. And the next test was, well, let's do an aggregate. Let's do a sum. To actually total something up instead of going to count row count. It's going to use a different, I don't know, this is an aggregate count by row group. So I'm grouping on product number against the whole table to get the count of rows per product. Again, it's obviously going to take a little longer on this one.
Is product ID a clustered index on that table?
Let's check. I don't believe so. Yes, it is. So we got our result. Again, it's basically a table scan, 23 seconds. On our other two. Oops. You know what? I'm going to go ahead and do this just in case. And again, total results in 3 seconds from 2 different queries against 2 different index types. In our elapsed time, less than a second there, about a second there, and 1967 and 1690. So again, I mean, we're seeing a pretty significant impact. I'm actually getting better numbers now when I tested this the first time to grab the numbers.
Using link.
I guess. Well, I shut some things down, so it has a little more memory. So then the other would be a sum, actually calculating the sum, an aggregate of the quantity, the actual cost, and then doing total extended cost. The first two are kind of meaningless, whereas the third one actually makes some sense. And I need to clean, execute. Again, you're not restricted at all on the kinds of queries you can write. The optimizer is going to figure out the best possible use of the indexes that are available and do that. So you're not really limited in any way in what you can do with these. You do have to test, and that's why it's important to do this. There's at least one case where the standard table works faster. And that's to be expected, depending on the type of query you're throwing at it, how selective it is. And it's really something you want to also monitor over time because of the fragmentation that can start to occur within the column stores. So again, that was 23 seconds. All of these are basically a table scan. They're going to come out about the same. So let's run our other two. (2018) and 25/16. My buffers again. I keep doing Control R.
Thank you.
All right, so this next example, I'm going to join to that large product table, and I'm actually going to use some of the columns on that table as part of my result set. So I'm taking product ID from my fact table, the name of the product number, the year of the transaction, the month of the transaction, and then taking that total percent calculation with that. So it's more of a typical query, something you might do, and then running that. So this one's going to take me a while to run on this guy.
And Clayton, the only table you have the columnar index on is the transaction?
Yes. Okay. Yeah, I did not do the product table, probably could, but it's under 1 million rows. It might, it probably would help, but depending on which columns in it you're referencing. But I just, for this purpose, I wanted to keep it simple and do just the one. I mean, that's something you can try and see, oh, that really helped. Smaller tables are not good candidates for indexes. Just not what they're intended for. Okay, so that, again, that took 33 seconds. So that was doing a join. It's always expensive. So let's go ahead and run our next two. Oops. Against our non-clustered and clustered. And these definitely take a little longer because of the other table and join operation. But you can see, started getting results back in 10 seconds, and we're done in, I think, about 20, if I remember right. And one of these is working better than the other. Okay, first one's done. So that's our total elapsed time. So it's still about twice as fast as a normal table, just with the index on the product. So next, let's actually run a query where we're filtering our dimension, going after a smaller set of rows. So here, basically the same query, but I'm going to filter where color is red on the product and subset that a little more.
So is there a way to do a query hint and say ignore the columnar index?
Not if it's clustered, because that is your table. There's no way you could do that. There are, I don't know what all the hints that are available, but there are some.
I was just thinking if you had a table on its way to becoming big, that you wanted to not use that until it got to 10 million or something. Create it when it gets that big.
I don't know. I don't think that's by much. All right, so that was 6 seconds. So this is a case where we actually got worse performance than standard query. Because here we were filtering on the non-clustered table joining to the clustered table, and it actually had a negative impact compared to the regular query. But there's not many cases where that happens. So let's cleaner buffers one more time. And I think this is the last one. So filter to a fact table joined with large product dimension, and do our work. In this one, I'm actually going to cheat a bit. I'm going to start the last two first, just to get some data buffered from that second table, product table. I'll give that as the advantage to the other query because this one beats it hands down. The difference here is I'm filtering on the fact table. I'm saying where the actual cost is less than $10. So I'm filtering on clustered columns or index instead of filtering on non-clustered table, and the impact of that is pretty significant in comparison. Okay, so 8102, that guy. Go get this one. And this one takes a while. So there's definitely, depending on what operators you're using, you're going to get slightly different performance characteristics from the column store index. So again, you really want to test your solution if it's going to work. And that's where looking at the query plans, turning statistics on, taking a look at this, the results can really make a difference in what decisions you make. Right, so that's just 29 seconds. And there's our completed chart. So, are you interested in cluster column store indexes yet? Have I made a compelling case yet on performance? And that was my objective, get you guys interested in something, give you the links to learn more if you want to go delve deeper, and let's continue the conversation for the next year. Things are really changing in the industry in terms of in-memory and leveraging in-memory technologies. It's not just Microsoft, it's all the platforms are doing it. So it's going to become very competitive, and I think it's something that, in terms of resume building, if it's something you want to get some skills on, I would talk to your boss, try and get something going. If you don't have 2014, work in a demo environment, run something like this and show them the numbers, and see if you can't get some action. I really think from the perspective of running things in memory, it's a great way to do it. It solves a lot of problems that are pretty typical, and it allows you to put new legs on old reports, if you will. So if you have reports that are reporting services with SQL, you can change what's under them. They don't need to change, and you'll get a performance boost. Yes, sir.
Could you open up Mansion Studio there and see how big those tables are, just by right-clicking on them and checking properties? I mean, are they actually stored in your RAM? You said you had 12 gigs of memory on your machine, or is there some on the hard disk?
It's actually great. You can show them all three of them right now.
Yeah.
It's pretty remarkable.
So let's go properties, storage, index space is about a gig, row count, data space is about a gig. That's my standard table. Clustered one, storage, index space, 0, because I had to drop all the indexes on the table. Row count, data space is about 300 meg, 300, 400 meg. There's some other DMV queries we can look at here too. In our non-clustered, that was the non-clustered. The non-clustered is going to be cool. Different here. Index space, 454. The data space is the same, 1.5 gig. So, yeah, it's right there. There's also DMV views that will, like I showed you those earlier. Where is that file? This is one of the ones that I sent you the links to. There's a whole set of queries against the metadata that allows you to see what's going on. So I got to go total size, CTEs, and go. Oh yes. Cancel. Let's cancel first. So that's giving me some size information there. Size per index. Again, this is all put up there on that the FAQ, and they've got. I want to get the one that showed me the segments. Size per column. Here we go. That's one.
I think at the end of the day, you'll see that, the 2012 version is a non-clustered, so it's a little secondary, so you won't see as much space savings on the actual table size. And when you get to 2014, it becomes clustered. That's really how the table's sorted. So you'll see not only performance, but compression in 2014, a lot different than you'd see in the 2012 version.
Yeah, so here, by looking at the space per column, it's got the actual cost, got the segment size, transaction ID, each one of the different types, dictionary size. You can see the different approach. It chose not to use a dictionary for the actual cost and transaction ID, where it did for product ID and some of the others. So, all right, there we're, not this one. All right, so this is a example from our buddy from the Netherlands that he's got some good queries on his blog as well. I'm looking at the data. So there's my table, and this is showing me the fragmentation percent of my index. So if I go and do some work against that, say let's delete the top 1,000 rows a couple times, maybe 3, 4, 5, or 6, 7, 8, 9, 10 times. Now run that same query. Start to see we've got fragmentation 0.03%. You can also look at the segments. You've got another query that breaks down by segment, and you can see how effective your different segments are, how much free space. So we could also do supply. Actual cost. So this is going to do a big update. It actually helps bring up the query, right? All right, so this is going to take a little while because right now it's going flagging those rows as deleted in the delete index, and it's writing the updated rows to the row store. It's then going to, if I've updated over 1 million rows, which I believe I have, it's going to get that tuple mover and move them in. So it's going to do a bunch of work, and that's the disadvantage. This is not fast.
Your processes are pegging right now?
Oh, yeah, let's look at that. Not too bad. But they definitely picked up. Probably because I hit that amount equals 0, that's going to be a particular segment. Hitting a particular segment or two really hard. Now, I didn't run this test, of course, on this data set, so I don't know how long it's really going to take, so apologize on that. But I'm basically done. If there are any other questions, I got a couple other slides just with the resource links. And if you guys have other suggestions for the group, again, survey is going to be coming out. I'm going to be working with Phil to get a survey out for the BI user group as well, so that we can make sure we've got topics and presenters that meet the needs of the audience, and make sure that we grow our group. We also are always looking for presenters. I'm looking at Pete because I haven't seen him up here in a while. And I know he's a good presenter. So I know, a lot of people are, I'll be honest with you, I'll tell you a story. I failed an icebreaker at a speech club in college. That's how terrified of public speaking I was. I could hardly get 3 words out without choking or stuttering. I can do it now, a lot better, a little bit better. And if you ever need someone to talk to about that or getting over fear of public speaking or how to do it, talk to me. I'm more than happy to help you out. Mentoring is one of my bullet points on my business card, so willing to help out there. So I think I may have killed my machine with that update. So I think we'll switch back to the deck and see what goes on. There.
You announced the services in 5 years.
What do I see? It's all going to be in memory. The MDX store. The reason for the MDX version was managing data on disk. How do I get aggregates generated? How do I make it fast to go from a big database to a hierarchical data store that I can access my data very quickly? And if I can do it in memory compressed, I don't need that. The query language, I love MDX. You can do stuff in MDX you just can't easily do in SQL. But there's also stuff you can do in SQL you can't easily do in MDX. And now to throw DAX, the query language for tabular on top, there's things you can do in there that are really cool and easy to do. And then there's some very basic, simple things you just beat your head against the wall and say, why won't this work? And it's a learning game again. You got to learn. Whereas I really hope and pray that MDX ends up still staying as part of the tabular model, so that all that code, all that work that people have done, learning they've done, moves forward with the product. But if I can do it all in SQL, I learned SQL first. And I've learned, I did something years and years ago doing table folding and pivoting with a time dimension where I could do year over year and year-to-date results in the SQL query. And before anybody had ever done anything like that, I had that working. I did a business objects model at Anheuser-Busch that did that. And I heard 10 years later that nobody could touch it because it didn't know how it worked, which isn't necessarily a good thing, but it still worked. So there's SQL you can do amazing things with. And I think the tool sets that are out there are getting to be really interesting. One of my favorite bloggers, Brent Ozar, kind of had a rip lately on the whole analytics side of things. But he's always ripping on that. So I'm kind of like, whatever. Whereas what I look at it is we're producing a stream of information. How you consume it on the other end, whether it's a dashboard, Excel, Tableau, ProClarity, Pyramid Analytics, or other tools, I really don't care. I want to take the data from the business, make it usable, make it clean, make it trusted, and serve it up in a way that the most number of tools possible can make sense of it and make it easy for the users to use. So if you think about, Brent used the analogy of the gold rush. He said, when there's a gold rush, you don't want to be digging for gold. You want to be selling gold mining supplies. I look at kind of that value stream, the data. You want to be providing data and helping that process. I love doing visualizations and that, but once you're done, you're done. There's less value once one's done to doing the next one. Whereas there's a lot of value in making it possible for the analysts to be able to do that work themselves. So I think that's more where BI is going. And all these tools are Julia, all Hadoop, they're all just other ways of transforming, cleaning, and managing data. And they're all coming together. That's my Scout Master in a minute. So, all right, next slide, and I am done, and we'll move on to our next speakers. Some of the references. Eric Hansen has the Columnar Index Fact on TechNet. Mika Neubauer, definitely check out his posts on column stores. Microsoft Research white paper kind of goes through their logic and reasoning, how they came up with it, and what some of the other products are doing and how they're different. Joe Sack has a great blog on SQL skills. We went through some of the details and how the segment elimination works. Lots more internal stuff on his post. There's also tons of SQL Pass presentations. I have to give credit to Joe Chinchilla, I think is how he says his name. I didn't see his presentation in Pass, but I read his deck and looked at some of his examples, and they were great. So I'll give him kudos. There's just a lot of information out there. It's hard to find, but if you use these first few links, they'll take you to the vast majority of what's out there. So again, thank you very much for your time. And